All right, so this is day 2 of the 3.5 notes. It'll go right along with worksheet number 6 that I'm going to give you towards the end of the hour. In your notes packet, it just follows right after the first day of 3.5. So on the top, it just says more on solving equations, and then it leaves a space for a rule. Does everyone know where we're at? All right, so we're going to jump right into the rule for solving these. Today we're going to work mostly with problems that have fractions or decimals. So the rule we're going to follow is we're going to multiply every single term in an equation by the LCD if we're working with fractions, or by a multiple of 10 if we're working with decimals. These are both strategies to get rid of those right off the bat and then solve an equivalent equation without the fractions and decimals. So it's just sort of one more strategy for solving these equations. So whenever you're solving an equation, one of the rules is that whatever you do to one side, you do the same thing to the other side. And as long as you're doing the same thing to both sides of the equal sign, it's fine. Okay? Pretty much anything goes as long as you're doing it to both sides. So, the trick here is to find the least common denominator. So if you were going to, let's say, add all these fractions, a fraction with an 8 on the bottom, a fraction with a 3 on the bottom, a fraction with a 2 on the bottom, a fraction with a 4 on the bottom, what would the common denominator be for those 4 denominators? 24. 16 would work if the 3 wasn't in there, but that one's screwing that one up for us. So 24. So the trick that I'm going to follow today is I'm going to multiply everything on the left side by 24 over 1, and everything on the right side by 24 over 1. Okay, I am going to write this out maybe in a few more steps than it will take you, but I'm going to write 24 over 1 times 7 over 8 minus 24 over 1 times 1/3 n equals 24 over 1 times 1/2 n minus 24 over 21 times 3/4. All right, so I distributed to both sides. And remember, as long as you're multiplying both sides by the same number, it's okay. The equation is still true. Now, the whole point is that this should get rid of all of the denominators for me. If it doesn't, you pick the wrong common denominator. So, in that first term, 8 goes into 24, right? The 8 becomes a 1, the 24 becomes a 3. And then that whole term is now 21. Everyone see what happened there? Minus, in the middle, the 3 becomes a 1, the 24 becomes an 8. So 8n minus yeah. Sorry, I was looking at the wrong spot in the equation. Yep, that's where the equal sign goes. Next we have the 2 and the 24. That'll become a 12, right? So 12n minus, and then in the back we'll have 1 and 6. And then what's 6 times 3? 18. Now, if all the fractions did not go away, you did not multiply by the right number. Okay? But for us, it worked, right? Does everyone understand the trick? We'll practice it a whole bunch today. So if you're not quite there, that's fine. All right, what do I do next? Yes.
Move the 8, add 8n to 12n.
Very good. Add 8n to both sides. So that's going to be 21 equals 20n minus 18. Then what? Add 18 to both sides. Then that's what? 39 equals 20n. And then divide. So you get 39 over 20 equals n, or n equals 39 over 20. Do not make it improper, or sorry, back that up. Do not make it a mixed number. Leave it an improper fraction. Don't make it a decimal. It is just fine the way it is. 39 over 20. What are your questions on this process? It's kind of long, but it's nice to get rid of those fractions right off the bat. The only drawback is that you usually end up with a fraction at the end anyway, but it's a lot nicer than getting common denominators and doing all that stuff. Simplifying a big fraction, it just kind of works out a little nicer if you get rid of the fractions, deal with it, and then they just kind of pop back up right at the end. What are your questions? All right, let's check out the next one. Yes. So I'm going to multiply by 6 over 1. And on the right side by 6 over 1. Distribute to each term. So 6 over 1 times m over 3 minus 6 over 1 times 1/2 equals 6 over 1 times m over 2 minus 6 over 1 times 1 over 3. Now I'm going to start hopefully seeing my fractions turn to whole numbers. So what happens in the front? Good. So I'll have 2m minus 3, good, equals minus, good. All right, from here, do what? Subtract 2m. Good. Get those m's together first. Those are gone. Don't drop that negative, okay? It stays with the 3. That's 1m or just m. Then what? Add 2. So this one actually isn't going to give us a big nasty fraction at the end. So m equals -1 is going to be my answer. What are your questions? And just like any other equation, if you want to plug that back in when you're done, go for it. You should end up with like the same number equals the same number. That's how you know that it's true. And fractions are scary, but if you have a calculator, you just type it in. So we do -1 ABC3 minus 1 ABC2. Same thing on the other side. You should get the same fraction. Any questions? All right, let's keep it going. Here's number C. All right, now this is a similar trick, but we do it a little differently because we want to get rid of the decimals. How many places after the decimal is there in the one with the most decimals? 2. How do you move a decimal point 2 places? You multiply by 100. If you multiply by 10, you'll only move it 1 place. So the one with the most places after the decimal point determines the whole problem. We need to move 2 decimal places. So I need to multiply both sides by 100. Remember, whatever you do to one side, you have to do to the other, or you're disrupting the problem. It's no longer equivalent unless it's the exact same number on both sides. All right, so I'm not going to write this one out because these are a little easier actually. So 18 times 100 is 1800. Minus, we'll move this decimal twice. So that's going to be 380. X equals, move this decimal twice, 736. Minus, move that decimal twice, 190. Make sure you're putting those zeros for placeholders. If you have anything less than 2 decimals, like 1 decimal or no places after the decimal, you should be having some zeros. Like this one didn't have a decimal, right? We weren't getting rid of any of the places after the decimal. The decimal is already kind of at the end, right? So that's where 2 jumps gave us 2 zeros. Here we took care of the 8, but we had an extra jump, so we have an extra 0. Does that make sense? Here we only had 1 jump, so we have an extra 0. This is why we needed the 2 jumps, so no extra zeros on the end. Now, we solved this one just like regular. So what would I do to both sides? Yes?
You would add 380x to both sides.
Very good. We're going to add 380x. And you add x's to where you see x's. So those are gone. I still have the 1800 equals 736. And then I'm getting 190. X again, right? Because it's like 380 minus 190. Keep the x's. All right, now what? What are you guys coming up with? Okay. Then what? All right, divide both sides by 190. Good. So I would actually prefer the answer 28 over 5. That goes against what I literally just got done saying in your homework. I told you that if your problem had a decimal in it, that you could give the answer as a decimal. So that's fine. What is the decimal answer? 5.6. I will honor what I said in the homework portion of the lesson today. If it starts with decimals and you want to give it to me as a decimal, that's fine. I still always kind of prefer this. But if there is a decimal in the problem, I will accept a decimal as your answer. What are your questions? So I just heard, is this a bodyguard problem? Kinda. But if we multiply by 3, on both sides, we won't get rid of all the fractions. So think of the strategy for getting rid of all the fractions. What do I want to multiply by? 15. Good. Now, since there's only one fraction on each side, I'm not going to rewrite it to do my simplifying step. I'll just go from here. So that'll become a 1. That'll become a 5. This will become a 1. This will become a 3. Now, the big deal on the left side is that it's not just the 2r that's being multiplied by that 5. It's both of those. So make sure you're distributing that 5. So 5 times the 2r is 10r. Minus 5 times the 3 is 15. Mm-hmm. And then equals on the right side, 3 times 3 is going to give us 9. Yep, go ahead and add 15 to both sides. 10r equals 24. Good. Which is 12 over 5. Very good. Questions? All right, here's the next one. Okay, do we have any ideas? Yes, 15 won't do it for the 10. All right, I'm going to write it out just so I can simplify properly. I don't want to move too fast. Oop, I'm out of space, sorry. Okay. Let's try to get the next line a little better. So, what happens to the 5 and the 30? Yeah, a 1 and a 6. Good. And 6 times 2 is 12. Y plus 3 and 1, right? Then a 1 and a 10. So 20. And then back here we have a 1 and a 3. So that's a 9y. Everybody with me? Mm-hmm. Sorry about the writing. I wrote a little big on that middle step. All right, what next? Yes? Yeah, you could subtract the 12y part if you wanted. I would not. I just don't like introducing negatives when I don't have to. So this would be 21y plus 3 equals 20. Take away 3, good. So 21y equals 17. And then what's the final answer going to be? 17 over 21, good. What are your questions? Does anyone need more time with this one? I know it was a lot. What's the magic number? 12. Good. Whoops. I swear I am dyslexic. Okay, 12. Undiagnosed. Alright, so 12 over 1 times 3 over 4 minus 12 over 1 times 2 over 3x equals 12 over 1 times 1/2 minus 12 over 1 times 3 over 4x. All right, from here, the 4 and the 12 should become a 1 and a 3. So we have a 9 up front minus 4 over 1. So 8x equals 1 and 6 minus 1 and 3. All right, who has questions? That's kind of the magical step right there. That's where it all happens. All right, now what? Let's add the 9. Since it's bigger, we'll get rid of our negatives. Can't guarantee we'll keep them gone, but we can try. So that's 1x or just x? Nope, we're going to get them back. What do we do here? Minus the 9. So x is going to equal negative 3. Questions? All right, here's G. I don't know why the T's are so big. All right, any ideas? Just 2 will work, yeah. All right, so when you distribute, in the front, the 2's would go away, right? You just have 5t minus, and then just 2 times t is 2t. In the back, you'll have 6 plus 3t. All right, right here. That's 3t equals 6 plus 3t. Uh-oh. What happens? They're going to be gone, okay? 3t minus 3t is 0 equals 6. Does 0 ever equal 6? No, this is actually a problem where we will have what's called no solution. When all your variables cancel out, if you have a true statement, like 0 equals 0 or 6 equals 6, then your answer is many solutions or all real numbers, because no matter what number you plug in, it will work. If it happens like this, though, there is not a time where the number 0 equals the number 6. So no matter what you plug in for t, this will never be a true equation. So that's why we say no solution. So you could write no solution. Or this symbol is called the empty set symbol. It means that there isn't a value that works here. So same idea. Any questions? Kind of a fun one. No? All right. I believe this is the last one for the day. Does anyone have any thoughts on how to get this guy started? Yeah, we can distribute. All right, we have some like terms. So on the left, I'll have 6y plus 19 equals, on the right, I'll have 6y plus 19. All right, so let's get our y's together. What happens when I try to subtract 6y from both sides? They cancel out. I'm left with 19 equals 19. So you will have the answer all real numbers. Yes, ma'am. So did you end up with 0 equals 0?
Yeah, or 6y equals 6y.
Yeah, so the thing that I want to see is that you made all the y's go away. That's the tip off. And then you're either left with a statement that's true or a statement that's not true. If it's true, your answer is all real numbers, because no matter what you plug in for the y's in this case, it will work. Or it's no solution if you get a statement that's not true, because no matter what you plug in, it won't work. All right, what did we learn today? Just squeeze it in up top, maybe by the title. What did we learn?
More solving equations.
Awesome. More solving equations. If you want to be more specific, you could say equations with fractions and decimals and special answers. That's kind of what we hit today. But I'm okay with just more solving equations. So I'm about to give you a worksheet. It's day 6. So you have the rest of class to work on it, and then that will be due tomorrow.